Hello dear students, welcome once again to my channel Maths in Minutes with Priya. Today we are going to start with the new topic, that is ratio and proportion. Today it's going to be part 1. This is clip 26. In last 3 clips we learned some speed math tricks about cube roots and square roots, and before that also we have covered some tricks in various chapters such as factorization, divisibility, percentage, etc. Now you may think that why do I need divisibility? Why do I need factorization? In reasoning also you are going to need it, because in reasoning sometimes they give a number series, and that number series you need to find a number that doesn't match that series, or maybe 5 numbers are given to you and you need to find the 6th number, and most of the students are not able to understand the pattern. Now what happens when you know the factors of the given numbers, it becomes very easy for finding the pattern. So it's my request to you that watch divisibility criteria. 3 parts I have made. We have learned divisibility criteria of many prime numbers also, and also please watch factorization, how to factorize fast. It helps you a lot in enhancing your speed. So let's begin now with today's topic, ratio proportion part 1. Since this is the very first part of this topic, first I am going to cover all basics, and from part 2, part 3 and part 4 I am going to cover examples with higher difficulty level. Today also we are going to cover few examples, but part 2, part 3 and part 4 every time I will raise the difficulty level. So please keep watching. Now let's begin with basics of this chapter. If you have forgotten the basics, please concentrate, and even if you know the basics, still please focus, because you may get something new that you didn't already know. So let's begin. What is a ratio? Ratio means it's a way to compare two quantities, and it's written in the form x is to y or x upon y. And proportion means it's an equation. See this equal to sign. It's an equation that says that two ratios are equivalent. X upon y is equal to a upon b, or x upon y is equal to 3 upon 4. So denominators are non-zero. That is the condition. These are the definitions of ratio and proportion, not actually mathematical definition. These are very easy language definitions. So let's now see how it is used in mathematics. When I say x upon y is equal to 3 upon 4, or x is to y equivalent to 3 is to 4, it means when x is equal to 3, then y is equal to 4, or when y is equal to 4, then x is equal to 3. Their values are dependent on each other. They follow each other. It means if x becomes 30, y will become 40. If x becomes 300, y will be 400. If y becomes 200, x will be 150. So it's kind of chasing each other. Their values are not individual, their values are dependent on each other. So here if you can see, x upon y is equal to 3 upon 4, same as 30 upon 40, same as 300 by 400, same as 150 upon 200, same as 15 upon 20. I have divided both this by 10. Now if I multiply 3 and 4 by 6, I get 3 6 are 18 and 4 6 are 24. So to find equivalent ratios, what I can do? I can either multiply numerator and denominator by a number, same number is very important, or I can divide numerator and denominator by the same number. Still we will get equivalent ratio only. So when I say 300 upon 400, it is same as 3 upon 4. It is same as 150 upon 200. It means we can find infinite equivalent values. It can be 3 crore upon 4 crore also. we can find infinite equivalent values. X upon y is equal to 3 upon 4. Now if I add 3 and 4, it becomes 7. It will mean that if there are 7 objects, X will have 3 and Y will have 4. That is the meaning. So if there are 70 objects, X will have 30 and Y will have 40. It will go on like this. So if I add numerator and denominator, total is 7. Out of 7, X has 3, Y has 4. Suppose there are 3 numbers in a ratio. A is to B is to C equivalent to 5 is to 3 is to 7. So straight away what can I say? If I add these 3 numbers, I get 15. That means out of 15, A has 5, B has 3 and C has 7. So if I want to put it in fraction form, I can write like this. Total there are 15 and A has 5. So A is 5 upon 15, B is 3 upon 15 and C is 7 upon 15. So if there are 15 objects, this is true. But what if there are 75 objects? That means what we'll have to do now? This 75 I'll now multiply by 5 upon 15 because A has the fraction 5 upon 15. So 75 will be multiplied by 5 upon 15. B will have 75 into 3 upon 15 and C will have 75 into 7 upon 15. Getting it? Now let's use these principles to solve the examples. First we will solve very easy examples and later we will move to difficult ones. An amount of money is distributed among 5 brothers P, Q, R, S, T in the ratio 3 is to 1 is to 2 is to 5 is to 4. If total amount is 7,50,000, then find the amount given to R. The numbers in this ratio pertain to PQRST. So P is equivalent to 3, Q to 1 like this. Now what we just saw, if we add this, what do we get? 3 plus 1, 4, 4 plus 2, 6, 6 plus 5, 11, in 11 plus 4, 15. And we are asked what amount R will get. Now R pertains to this number 2. Total is 15. So R is going to get 2 upon 15 of 7,50,000. So how much R will get? R gets 7,50,000 into, since R pertains to 2, 2 upon 15. 15 ones are, 15 fives are 1, 2, 3, 4, 1, 2, 3, 4. So this is 5 twos are 10 and 1, 2, 3, 4. So R gets 1 lakh out of 7,50,000. Very clear? Sometimes they might ask, find the combined amount of PST. So here what we can do? Either we can find individual of P, then S, then T and then add, or the shortcut will be this. We want PST. Now P is 3, S is 5 and T is 4. We can take their total. 3 plus 5, 8, 8 and 4, 12. So out of 15, combined they are going to have 12. So what I'll do? I'll multiply 7,50,000 by 12 upon 15. Since out of 15, they are combined, they are going to have 12 parts. Six lakhs. So together they are going to have 6 lakhs. Sometimes the question can be like this. S has how much more than Q? Now S is 5 and Q is 1. What is the difference between 5? So Q is going to get 1 part, S is going to get 5 part. So difference is 4 parts out of 15. So the difference is going to be 7,50,000 into 4 upon 15. That is going to be the difference. We can either find part of S and then part of Q and take the difference, that is also fine, but this will save our time. 4, 1, 2, 3, 4. You need to be very careful about these zeros. So that means S has 2 lakhs more than Q. There is one more way of solving this which is generally commonly that is used, so let's discuss that also. When I say PQRST are in this ratio, it means there lies some common multiple. This can be either 30, 10, 20, 50, 40. This can be anything and they all will share a common multiple. As I said, I can multiply or divide by the same number to keep the ratio equivalent, isn't it? So how we can solve this? We can assume, so like this, let the common multiple be X. So P becomes, share of P becomes 3X, Q 1X, R 2X, S 5X and T is 4X. Look at this equal to sign. Now I have converted this ratio into this equal to sign. So X becomes rupees. X is rupees and that is common multiple. P will have 3X rupees, Q will have 1X rupees, R will have 2X rupees, like that it will go. And together how much they will have? 15X rupees, isn't it? Now the question is, find the amount of R. Together it is 15X and the total money is 7,50,000. That means 15X is equal to 7,50,000. You understood now how it came 15X? We added 5 numbers. So it became 15X, that is total 7,50,000. So X is this divided by 15, which comes out to 50,000. So X is 50,000, that common multiple is 50,000. And now we want the amount with R. R is what? 2X and X is 50,000. So that means R gets 2 into 50,000, that is 1 lakh. So here also we found R gets 1 lakh. Here also we find R gets 1 lakh. This is the more common method that is used. Let's see some more examples. Money is distributed among A, B, C, D in the ratio 3:2:1:4. If A gets 5,000 less than D, then what is the sum distributed? So here what we can do, we can assume common multiple X. Let common multiple be X. That means A gets 3X, B gets 2X, C gets 1X and D gets 4X. Now we have converted this ratio into rupees. These many rupees A, B, C and D are going to get. Clear? Now they are saying, now total sum is not given to us. We need to find it. But they have given us one relation. A gets 5,000 less than D. This is A and this is D. A gets 5,000 less than D. So when I subtract 5,000 from D, I'll get amount of A. So let me subtract 5,000 from 4X. And that's how I'll get 3X. When I subtracted 5,000 from D's amount, I got A's amount. That relation is given to us. if I solve this, 3x will come here, 5000 moves there. So x will be 5000. I'm sure all of you know how to solve these simple equations. So x is equal to 5000, and the question is, what is the total sum distributed? What is the total sum? Total sum is addition of all this total. 3 plus 2, 5, 5 plus 1, 6, 6 plus 4, 10. So total sum is 10x. And x is 5000, so it is 10 into 5000, that is 50,000. So total sum is 50,000. Very easy example. See, if you are learning ratio and proportion for the first time, or maybe you have totally forgotten it, please watch these examples, these easy examples again and again, so that when I raise the difficulty level, you shouldn't feel lost. You should be very fluent in these basic examples, and only then you can solve the difficult examples. So please watch this video again if you are not able to understand. Let's move to next example. In the same example, instead of total sum distributed, if they ask what is B's amount, then how will you solve it? Every time remember, first find x, that common multiple, and then you will be able to solve any example, any question. Like here x is 5000 and we want B's amount. Now B is what? 2x. B is 2x and x is 5000. So amount of B will be 2 into 5000, that is 10,000. Sometimes the question may be, what is the combined amount of B and C? Now combined B and C, 2x plus 1x, that is 3x, and x we already know 5000. So 2x plus 1x, that is 3x, 3 into 5000, that is 15,000. So once you get the common multiple, let the question be anything, let the last line be anything, you will be able to find it once you get the value of this common multiple. And for getting this value, you will need to use the relation given in the problem. Here we use this line, A gets 5000 less than D. Some relation they will give you, you need to use that and find a common multiple. If you already solved it and you got it right, very good for you. But don't be overconfident, because we are going to raise difficulty level, and that time we will see where actually we stand at what we need to learn more. Now let us solve some basic examples of these types. 3 ratios are given to me. A upon B is 2 upon 3. B upon C is equal to 12 upon 13. C is to D is equivalent to 26 upon 9. And I need to find A is to D, or A upon D, or D is to A, reciprocal. Now let's see how to find this. I'm going to write these 3 ratios here. A upon B is 2 upon 3. B upon C is 12 upon 13. C is to D, I am going to write it in the form C upon D, it's one and the same, 26 upon 9. And I want either this, this or this. When I look at these ratios, now if you already know how fractions are multiplied, then you will observe that if I multiply this, what will happen? B will get cancelled, C also will get cancelled, and I will be left with A upon D. That's what I want. Now if you have forgotten how the fractions are multiplied and divided, please watch the earlier videos. I have covered one complete video on multiplication and divisions of fractions and decimals. Please watch it, because it is very much required in every chapter. So now I am going to multiply these fractions, A upon B into B upon C into C upon D. This into this into this, and the right hand side will be 2 upon 3 into 12 upon 13 into 26 upon 9. This into this into this. What will happen here? B gets cancelled, C gets cancelled. So in the left hand side, I am left with A upon D. On the right hand side, 3 ones are 3 fours are, 13 ones are 13 twos are, can't be reduced further. 2 fours are 8, 8 twos are 16, and this is 9, so this is 16 upon 9. So A upon D is 16 upon 9. If the question is in this form, A is to D, then it will be 16 is to 9. If they want D is to A, that is reciprocal, what it will be? Straight away do the reciprocal. 9 upon 16, or 9 is to 16. Very easy. Now let them add any number of fractions. Then D upon E, E upon F. What you can do? You can just multiply, and then you will be left with A here and D here. Both ends will be left, and all these middle numbers will get cancelled. Next example. P upon Q is 3 upon 5 and Q upon T is 10 upon 11. What is P is to Q is to T? So we want all three numbers in the ratio. In the earlier question that we solved, question was about A is to D. So we got rid of B and C. We didn't want them. We wanted only A and D. But here we want all three. P also, Q also, and T also, and how they are dependent on each other, we want that. Now understand these basics. As we started this video, I said P upon Q is equal to 3 upon 5 means when P is equal to 3, then Q is equal to 5. Here, when Q is equal to 10, T is equal to 11. Q is in the middle. So if I make this value of Q equal in both the ratios, then P and T will also have some relation, isn't it? See what now I am going to do. Here they say when Q is equal to 10, then T is equal to 11. So I'll make this Q as 10, same as this. Can I make it? If I multiply this by 2 upon 2, what will happen? In ratio, we are allowed to multiply and divide numerator and denominator by the same number till the ratio remains the same, that we already saw. So this is 6 upon 10, isn't it? That means when P is equal to 6, Q is equal to 10, and when Q is equal to 10, T is equal to 11. So what we have now? P upon Q is equal to 6 upon 10. Q upon T is equal to 10 upon 11. When both these Q's are equal, this is 10, this is also 10, then you can straight away combine same as 6 is to 10 is to 11. 10. Q is 10. So when P is 6, Q is 10 and T is 11. They all will chase each other in this form. Got the meaning of combined ratio? Let's solve one more example. A upon B is given to me 5 upon 7. B upon C is given to me 3 upon 8. And I want combined ratio A is to B is to C. So just now we saw that middle number, whatever middle number, its value should be equal in both ratios, then we can straight away combine. Just now we solved the same kind of example. Now I want to make this equal, 7 and 3. Here what happened, it was easy, 5 and 10. So I just multiply this by 2 upon 2 and I got 10. Because 5 and 10 they are related to each other. 5 is a factor of 10. 5 into 2 became 10. Here B is equivalent to 7 and here it is 3. And 3 and 7, they don't have any common factor. So what I'll do to make them equal, I'll multiply this ratio by 3 upon 3 and this ratio by 7 upon 7. So see what happens. I'll pick 3 from here. This becomes 15 upon 21. Now I'll copy B upon C, that is 3 upon 8. And now this B equivalent to 7, I'll pick from here. So now what I have? A upon B is 15 upon 21 and B upon C is 21 upon 56. So is value of B equal now in both ratios? What I did? 5 upon 7 and 3 upon 8. I wanted to make B equal, but there is no common factor. So here it's 3 and here it's 7. I multiplied this by 3 upon 3 and multiplied this by 7 upon 7, and now they both are 21. So now I can easily combine, just like earlier example. When A is 15, then B is 21, and when B is 21, then C is 56. So my ratio is 15 is to 21 is to 56. One more example. X is to Y is to Z is equal to 4 is to 5 is to 7, and this relation is given to us. Minus 2x minus y plus 3z is equal to 64. Find the value of x. So what we can do here? We can assume common multiple, say m. Let common multiple be m. Because we know when numbers are in ratio, there is some common multiple. So x will be now 4m, y will be 5m, and z will be 7m. 4, 5, 7. I multiplied every number by m by assuming it as common multiple. Now this relation is given to me. Minus 2x minus y plus 3z is equal to 64. Now everywhere I'll substitute in place of x, y and z. I will substitute these values. Minus 2 in the bracket 4m minus 5m plus 3 7m is equal to 64. In place of x, y and z, I substituted their respective values. Now this is a simple equation that I need to solve. Minus 13 plus 21, that is 8. 8m is equal to 64. Therefore, m is equal to 8. 8 8 is 64. M is 8. What is the question? Question is find x. And what is x? X is 4m and m is 8. That is 4 into 8, 32. So your answer is 32. See, sometimes the question can be like this. Find value of, say, 4x plus 3y minus 9z. Something like this. So how we will solve this? Now we have x. In similar manner we can find y also. M is 8 and what is y? Y is 5m. We already have x, that is 32. We already found it. How we will find y? Y is 5m. We have value of m, that is 8. So y will be 40. Now we want Z also. Z is 7m and m is 8. So Z is 56. Now can I find this? Four in the bracket 32 plus 3 in the bracket 40 minus 9 in the bracket 56. And then we have to calculate this. Calculate and tell me the answer. Answer comes out to minus 256. So as I said, this last line can be anything. Find x, find y, or find value of this expression. The last line can be anything. Once you get the value of this common multiple that we have assumed, once you get this value, we can solve any question. Just like we saw in the very initial part of first example. Very clear? From next part, we will solve some difficult example. These were all basics, so please practice it so that from next part that also you will find very easy. If you haven't yet subscribed to my channel, please do subscribe. It's absolutely free. Maths in Minutes with Priya. Suggest to your friends too. I'm waiting for your comments, likes and suggestions, so please do so. See you in my next part. Till then, stay happy, stay blessed. Bye for today.